In this video I want to look at the mean value theorem for integrals and then one of the main applications of it, which is finding the average value of a function. So first let's look at the mean value theorem, and I have it written here that the integral from a to b of f of x dx is equal to b minus a times f of c. And what that's saying is, if say we have an interval here from a to b, we take the integral is going to be the area under the curve here. Well, our mean value theorem is saying that that same area will be equal to b minus a times f of c. Well, b minus a is the width of the interval. So this width is b minus a. Now if we think about it, f of c is some y value. So if we have some y value multiplied by some range of x value, we're really creating a rectangle. And what it will look like is f of c is whatever value on this curve that we can draw a rectangle from that has the width of the interval, and that rectangle will have the same area as the area under the curve. And as you see it drawn here, the rectangle goes a little over the curve in one place, a little under, but it works out where the area is exactly equal to the area under the curve. And it's just based on the idea that the area of a rectangle is length times width. Width is at b minus a, which is the width of the interval. The length or the height of it is the f of c. And that just it makes sense if you think about it, and it's really based on the fact that this works if a function is continuous on the closed interval from a to b, then it's going to have some finite value for this integral of being area between the curve and the axis. And if it has that value, there must be some rectangle to have equal area. The more important use of this is how we apply it in finding average value. Because if we divide by b minus a on both sides of that equation, we get the average value equation, which states that 1 over b minus a times the integral from a to b of f of x dx is equal to f of c. And f of c is the average value of the function. So if you took an infinite number of y values over that interval, added them all up, divided by how many you have, you find the average of them. That's what this f of c is. And practically we can't add them all together and find the exact average. We can take some points and approximate, but by doing this we simply do our integral and it will give us the average value and an exact value for it. So let's work an example to see how this works its way out. If say I give you the function f of x equals x squared on the interval from 1 to 4, and I tell you to find the average value. And the average value you can think of as being f of c. So we'll say that our b value is 4, our a value is the 1. So f of c is equal to 1 over b minus a times the integral from a to b of f of x dx. We calculate that, that's 1/3. The integral of x squared will be x to the third over 3, and we're evaluating from 4 to 1. So that'll be 1/3 times 4 to the third over 3 minus 1 to the third over 3. And when we simplify that, 4 to the third will be 64 over 3 minus 1 over 3. The entire thing's multiplied by 1/3, so we'll get 63 over 9, which is the average value of the function, and we can even simplify that because that'll simply be 7. So the function x squared on the interval from 1 to 4, the average value of the function is 7. And I could also say, well, tell me what x value that occurs at. Well, if you have a y value and you want to know what x it occurs at, you just set it equal to the function, solve, and you'll get x equals plus or minus the square root of 7. But we know we're working on the interval from 1 to 4, so discount the minus, we get the positive square root of 7 as the x-coordinate. And let's take a quick look at a graph to kind of reinforce what we're doing with that. And this is a graph that's hopefully familiar with you. We do a lot of examples with this curve. So if we're going from 1, our a value, to 4, our b value, we're saying that this area here is equal to 60, or is equal to this integral, which was 64 or 63 over 3. And we're saying that at x equals 7, or x equals the square root of 7, y being 7, which will be somewhere around here, we can draw a rectangle. The width of the interval and that given height, and the area of that rectangle we drew will be equal to the area under the curve, which we got with 63 over 3 there. So this is simply using integrals and using our mean value theorem. By dividing out the b minus a, we can easily find the average value of a function, which can be quite useful in several different applications.